We have two great speakers here covering some exciting and relevant topics: data science, TERR, Python, Spotfire. But before we get started, just two announcements. The first, just wanted to let you know about a new meetup I'm organizing AI in the enterprise. We have a few speakers, exciting speakers and topics in planning. So if you're interested, if you have some suggestions for speakers or topics you'd like to see as well, please feel free to reach out to me. If you have any questions as well, please feel free to reach out to me. And for the second announcement is Greg Mikowski.
All right, thank you. I'm Arita, the Association of Computing Machinery. It's a professional society for computer science. So we have 2 talks a month, a general computing and a data science. I have 2 events I wanted to announce. On September 16th, there's a Saturday day-long training class on predictive data science with R. So I'll be going through teaching a full sprint on how to do a data mining project. I want to separate myself out from opening up a R in a nutshell, covering horizontally everything about this, everything about this. And I want to dive all the way through one full pass of doing everything for a data mining project. And I've been deploying data mining models for about 25 years, so I'm going to try and add a lot of questions that you can take away to your projects on how you can structure them. Because a lot of times in a class, you start with a clean data set. There's a lot of things you can do to structure it, to identify a good problem to work on, and different things like that I'll be discussing. So that's one thing. And that's with Bay ACM, San Francisco Bay ACM. And the second is a small data science conference I've been doing since 2009. This is in mid-October, October 14th. And it'll be at PayPal in North San Jose. And we can host up to 20 or 30 data science speakers. So that's a low-cost event, $10, just mostly to cover lunch. There's a morning class on Keras and Tensor, on top of TensorFlow, if you want to learn an easy approach to get started on deep learning. So Greg Mikowski, that's at Bay ACM, R class, and data science. Thank you.
Awesome. Thanks, Greg. So what I'd like to do now is introduce our 2 speakers. We have Michael O'Connell, Chief Analytics Officer with TIBCO, and Troy Ruths, CEO and founder of Ruths.ai. So please help me to give them a warm welcome.
So thanks. Is that working? My microphone working? No. That's supposed to turn it off or something. Yeah. You want to do it? Hello. Hello. This one works also. Okay, so I'm super excited to have Troy out here. Troy runs Ruths.ai, a big partner at TIBCO, and hosted a site, exchange.ai, with a bunch of assets, including a bunch of Spotfire templates, data functions, and things like that. We're going to give you a tour of those assets, and we're going to talk about I'm going to show you how to build an analytic application using Spotfire and R. I'm going to show you a pre-built one featuring some H2O methods in addition to Spotfire and R. So just to get started, we'll go through what is Spotfire, get into the analytics and data science landscape, do the 2 demos, an app from scratch and an autoencoder, talk about our recent acquisition of TIBCO Statistica, which is a data mining workbench, data science workbench, and model management application, and then get into our community resources. Okay, so what is Spotfire? It's an analytic app development environment that has interactive visual and geo-analytics capabilities, including coding down at the street level. It has a tight integration with an R engine that we built from the ground up at TIBCO. It's called TIBCO Enterprise Runtime for R. It's a scalable engine, runs your R code as well as your CRAN packages. And has data mashup and data ingest capabilities where you bring in data, you join it on the fly in an in-memory application. You can also do in database, down into the database, calculations, aggregations, and bring that back into the in-memory application as well. And then there's a one-click publish to a web server that allows you to publish this out to folks with no client, just through a browser. They can experience that one-click visual, interactive, brush-linked dashboarding that has embedded in it the geocoding, the R, computer analytics, the data mashup. All of that comes out in a single file, so you don't have to go into GitHub and get multiple files. It's just one file that you can share around. But when you publish it to the Spotfire web player server, it hosts up in a thin client browser as an interactive brush-linked experience. So we're going to show you how that works today. But that's kind of the we're often put in the same bucket as Tableau and Click, which those guys are real visual dashboards, but we're an analytic application building environment that includes the R environment, data mashup, and one-click web publishing. We've been building out a growing community of analytic applications under this framework, both on the TIBCO side, where we have community.tibco.com, component exchange, an answer portal, ideas, documentation, office hours. And then on Troy's side, Ruths.ai, which has an app store, technical blog, there's a subscription, online training. You can make a Pinterest-style board to catch and assemble your various assets and share them collaboratively. And these sites interact, and we host each other's content through links. So some of the content is about 250 apps that we have on the combined set of repositories, including the Spotfire templates, but also including the data functions, which are the kernel of the R piece, or including the link to the data source, or the theme, the HTML5 CSS theme that you can point and click. You can save that off as a separate artifact, as a style to apply to additional Spotfire analyses. All those artifacts can be saved and managed, and they're typically saved and managed in your library that you might have at your company, but these two exchanges serve as extensions to the library. So you can come up to the TIBCO exchange and pull down the contour plot function that Troy's going to demo tonight. You can pull down the gradient boosting machine template that I'm going to demo tonight, and a bunch of other stuff, and then Troy has a huge number of assets that you can pull down from his site. So this engine that we're using, the TIBCO Runtime R, it took us about 5 years to build this. We own the S language and the S Plus product line through another acquisition of TIBCO, an acquisition of a company called Insightful. And so we put those engineers to work to create our own R engine. And we could then embed as a commercial engine into all the TIBCO products. And you can run your open source packages through it. But the fact that we have our own commercial license allows you to just embed that, and we can ship it to you. You don't have to do any installs of open source or whatever. You can run your open source code, but you don't have to install the engine. So this comes inside the TIBCO products, Spotfire, StreamBase, Grid Server, a number of products. It was while we were building the engine, we rebuilt it for high performance, so it runs bigger data sets than open source R engine, for example. It installs free with a bunch of products. There's also a developer edition that's supported by TIBCO. You can come into support.tibco.com and ask us questions about it if you hold a license for it. So what does that do inside of the Spotfire environment? When you point and click on a graph, you'll get a context menu. If it's like a time series, or you can right click and get a forecast. The TERR engine under the hood is doing that, for example. When you go into the expression editor in Spotfire, you can create expressions point and click, but you can also put R code into an expression. That becomes an expression that you then put on an axis of a graph. So when you slice and dice your visual analytic application, those graphs are automatically refreshed, and that R script is recalculated every time you slice and dice, drill down, brush, and so on. That just gets automatically recalculated. So that's an expression. You can also create data functions. Troy's going to build a data function tonight on the fly. I'm going to show some pre-built ones. These give you a point-and-click interface to all the columns in your Spotfire data. You can choose as inputs to an R script, R data function that you have inside the data function. Those get referenced and calculated in the R engine and brought back and added to a visualization, either as a line or a coloring or a new graph or a contour on a map. The map chart has multiple layers, and you can drop a layer right onto the map chart from your R calculations, for example. A very tight integration between the settings in the point-and-click environment of Spotfire for all the charts and the actual R engine that's running the additional calculations outside of the built-in Spotfire calculations. There's a predictive models menu inside Spotfire, and all the models there, the regression classification models are actually computed inside the TIBCO R engine. So you point and click your way to the setting up the model, and that gets calculated. You don't see the R engine in any of this stuff, you just see the menu selections. And then finally, you can use R and shape files to extend the graphics palette. So you can create customized, specialized graphs. I'll show you some of those we've done for, say, the high-tech manufacturing space, wafer charts. And they still become brush-linked and drill down across, the other parts of the visual analytic application. And so the way that ties together architecturally is you have the Spotfire analyst has this R engine installed in it. So I click, it's not really working here. And the server also comes with the TERR engine on it. You can connect the server to other engines, but it comes out of the box with the TIBCO R engine. And then once you've built an analytic application like Troy will do tonight, you just do save as to library, one-click operation, and it automatically is then published to the web client for folks to come around without a Spotfire license in a thin client and click around and get the same brush-linked experience. You can use, as I mentioned, you can use other engines as well as R. And then the Spotfire library manages, if you have credentials to the library, you can go and get those artifacts. You can get the template, the data function, the style, the theme, the connection to the data mashup. All of those are separate artifacts that come together in this unified Spotfire file and Spotfire analysis. And then these community sites, Troy's site and our site, allow you to import those artifacts as data functions and templates and do your analysis on them. So without further ado, that's the setup for tonight's conversation. Troy's going to go ahead and build one of these applications, using data that he's going to bring in. Take it away, Troy.
Thanks, Michael. Okay, so tonight's exercise is we're actually going to go through the process of using each of those components that Michael talked about, visualization, data, and the computation engine, to build an analytic app really fast that we can then share. This is something at Ruths.ai, we're a proud partner of TIBCO. We unfortunately don't get any money when Spotfire gets sold or used, but we use it because we love it. And the reason we love it is because we also like doing technical programming with R. And frankly, this is the fastest, easiest way to deploy R in an enterprise. I'm going to show you what I mean by that. Just a raise of hand, how many people have seen Spotfire before? Okay, so it's going to be first timers for some people. How many people are familiar with concepts like clustering? All right, that's good. Okay, how about principal component analysis? So pretty good. Okay. All right. Well, we're going to use a lot of these techniques and we're packaging it into a multivariate workflow inside Spotfire. So let's go ahead and get started. So I picked a topic that's near and dear to my heart, which is oil and gas. Now, the neat thing about this data set is, like as all data scientists, we don't really get to always choose the type of data set we're going to work on. So the neat thing is you're going to be seeing a new data set, and we're going to use these techniques to actually understand more about the variable, and then we'll use them in a multivariate model. Let's go ahead and get rolling. Okay. Switch this out. So what you're going to see is going to be like some of those sidewalk artists. I'm just going to build on the fly. I'm a technical founder, so this is what I do for fun. So I'm actually enjoying this right now because it's rare that I actually get down and play with the tools. So thank you for allowing me to play in front of you as I play with Spotfire. Okay. So this is Spotfire. Now the first thing I'm going to do is just load in some data. So I have a multivariate data set. This is a famous basin. It's around Denver. It's called the DJ Basin. So oil and gas is a lot like real estate. You're trying to find pieces of land that you want to buy, prove up value, and then sell it to the next bidder. So how do you find good places to buy for real estate? Well, you're going to look at all the different factors, what went to a good sale price, and then you're going to try to find those indicators somewhere else in order to buy up properties in that area. We're going to apply the same idea to oil and gas data. So it's the same concept here. So one of the keys I want to do this is because we have nice spatial data. So I'm going to open up a map chart. And it looks like I got kicked off the internet. Just one second. All right, we're back in. We won't be using the DR in tonight's demonstration. Okay, now we got our wheels on a map. So we have wells on a map, and let me open up the data table here. So this is Spotfire. If you've never seen it before, you get a set of pages, and then on those pages you can assemble visualizations. All of these visualizations are brush linked. So you can filter and mark, and they're very interactive. So if I grab some rows in a table, I can see where they are on the map, and vice versa. If I grab things on the map, I can actually see where they are on the table. These can be driven, so I can actually grab these wells right here, and go in and see details about these wells. So I'm going to make a scatter plot. I'm going to organize my page real quick. So we have lots of different variables that we brought in. The value of a well is based on how much oil it produces. So the column we're going to care about for the next 20 minutes is cum oil, your 12-month cumulative oil. And then there's lots of factors that go into the design of this well. And those are going to be our other multivariables that we're going to take a look at as we build and interrogate this. So one of the key things is lateral length. Lateral length is the length of the well that we're drilling. So typically, the longer that well is, the more oil it's going to produce, just at the surface area. The other things you can do is you can actually complete the well differently. So you can think about this like maybe using better siding or higher quality marble in a house. We're actually going to use better quality materials to complete that well, and we'll get more resources from it. But how much resources? How much should we use? How much should we spend? That's what we're going to try to figure out. So inside Spotfire, this is nice because I can actually dynamically grab different areas of the field, and these charts will populate. So right away, I can I like to say you can feel or touch your data, which is very different from a lot of other tools because you can't really interrogate the results as they come out. Okay, I can also duplicate this guy. Maybe I want to look at two variables at once, so I'm going to go back to lateral length. I'm going to grab all of them, see what the pattern looks like. So I can interrogate the data very easily. It's all connected. All right, so let's start doing something a little bit fancier. So this is a data science meetup. So we don't just want to visualize the data, we actually want to do something with it. So the first thing let's just do some clustering, okay? So I'm going to take this data set, and I want to cluster on it. So we're going to use an inline TERR function. So we're going to invoke that TERR engine that Michael was talking about. So I want to color by a cluster. So to do that, if I know what I'm doing with, I'm going to start by saying, okay, run this little piece of R code, and what I'm doing, I'm putting this all in to what you would write inside of RStudio or an R interpreter. So you sort of have to know what you're doing here. Bear with me. If this sort of scares you, I'll show you how we can get around this step first. So I'm going to go in and run k-means on this data set. So just kidding. This is where you can actually search and find and put in the column that you need to put in. So I'm going to put in my latitude, my longitude, and there it goes. Now it's running. There it goes. So I just ran k-means on the data set. It calculated the different clusters and brought it back. All right? Pretty cool. So I just wrote a really short piece of R code. Now, what if we wanted to actually use a different R function? So if you're familiar with clustering, there's lots of different clustering functions out there. So let's use the Clara function. So Clara is sort of like Pam, but it runs a little bit faster. So let's go ahead and use Clara instead of k-means. So I'm going to come in here, right-click, and go back to my custom expression. Instead of k-means, I'm going to use Clara. And then the only thing I need to do is grab my clustering package. So now it ran the Clara algorithm for me instead of k-means. It was that easy, super fast, right? So now I can even interrogate my data. So this is where Spotfire starts to jump out for me as a data scientist. After I run that clustering, I can now click on those different clusters and zoom in and see what those patterns were that it detected, right? I haven't done anything really fancy because I just used lateral length, or I mean location. Okay, so the next step we can take, this is sort of messy, right? Like we're not crazy about writing pieces of our code everywhere we want to use this function, because maybe we want to use it somewhere else. So what we're going to do is we're going to take this, copy it, and there's a lot of great data function capability packed with Spotfire. So I'm going to make a new function. So Spotfire comes packaged with lots of functions. I'm going to add a new one that's just wraps R. So I come in here and say new. I'm going to call it Clara. And then I say maybe
Robust.
Calls give someone a usage hint. Clara, I want to put the number of clusters in first, and then maybe column 1, column 2, like this. Right? It's going to return a real, and then I'm going to paste in that code that I had before. And the only thing I'm going to change here is match up the inputs. And say OK. So now I have a Clara function. So if I come to my custom expression, I can actually get rid of all of this and search Clara. Now it pops up. I now have Clara in that dropdown. It has that nice little doc string that I gave. So I can just call Clara, say, okay, I want 5 clusters, and I'll use my longitude, latitude. So now we've just taken something that is wrapping R, pretty complex, and you saw there was an editor, you could put whatever you wanted in there. But now we've exposed it in a place that a casual user could actually run your R code very easily, and they can switch out the columns. So I'm going to say OK. There it goes. So now it ran a Clara algorithm. It's doing the same thing, but I made it much more friendly. So if I wanted to get a little bit fancier inside Spotfire, you can actually hook this up in a really neat user interface. So say I want the user to be able to dynamically change those number of clusters. I can just come into this text area, say edit text area, and I can create a document, no, not that one. I can create a document property for, let's make a slider. So here, I can say the number of clusters I want them to go through, so 1 to 10. I'll do an initial value of 4. And then I'm going to call it number of clusters. And it's going to be an integer. So, okay. Okay. And then the only thing I need to add is tell them what it is. Let's say. Okay, so my cluster count. There we go. I think I just need to give it a couple more steps. That should be the one. Yeah. Okay. So now I have a nice slider like that. So I want to hook that up to the number of clusters. Let's say custom expression. And here I can use this nice little document property that I put in. Really, that's just text replace for the evaluation. Say OK. And as I change this, it changes the number of cluster calculation. All dynamically on the fly. Isn't that great? Come on, that's cool, right? That's cool. I just grabbed a random function. All right, I see this is a tough crowd. Okay, I will get there. I will impress everyone. Just give me a second. We're just warming up. Okay, so the problem with just running clustering like that is we're not dealing with normalization. I brought in a new data set. You know, these things have different scales. I can't just run Clara like that if you're used to these clustering algorithms. So I need to do some normalization. There's a great auto-normalization technique for dimensionality reduction, which is PCA. This is commonly thrown in, especially when you have a new data set and you're trying to understand how much information you have in the different columns, and also normalize them so they're at least all orthogonal and linear. So how do I do that inside Spotfire? You might say, I have no earthly idea. Can you do that inside Spotfire? Well, you better believe it, you can. All right, so I'm going to show you where some of this community is really nice and it works together with what you're doing. So you might say, I need to do PCA in Spotfire. So what does anybody do if they need to do anything these days? They Google PCA in Spotfire. Okay. Whoa! What is that link? Thank goodness there's an awesome technical blog that people post to every single week on new topics for how you can actually drop these things inside Spotfire. So if you want to bring PCA inside Spotfire, you may not know exactly the best way to do it. That's why we blog about it a lot. We try to build good community resources that you can come get access to it. So if I scroll down here, a lot of discussion on what PCA is, a video doing it, and then this awesome code snippet. So what this code snippet is doing, if you read the blog, is telling you, hey, you want to run PCA, you might find some PCA code and running it on R, but how do I do it inside Spotfire? So we have this nice little code snippet. So I'm just going to copy this shamelessly. And then I'm going to come back to Spotfire. Okay, so this is the part where I'm going to make a data function. So I want to run PCA on this multivariate data set that I've created. So to do that, I'm going to create a new data function. So I'm going to register a data function. And call PCA. So this is an example of creating a data function from scratch. And I'm going to show you how to make it from scratch first, and then I'm going to show you how you go steal someone else's data function and just plug it into Spotfire. So the first thing I'm going to do is write this thing from scratch. It's actually not too bad, because someone has already written it for me. I just need to hook it in. So I pop this in here. I have this data input, so I'm going to double click that guy, select it, and say this is an input parameter. And it's going to ask me what type of values it's supposed to be. So I'm going to say, all right, you're a table. And I can only take integers, reals, anything numeric, because this is PCA, so it doesn't work on strings. So I have to do some dummy encoding in order to run this on strings. So we're not going to go through that process right now. We're just going to use numeric values. So I'm going to say I can only send in numeric columns. Okay. If I was critiquing myself, I should always put in descriptions, right? Now I need to match up the output parameters. So if I come here, we have this rotated values, which we're going to output. So I'm going to say you're an output parameter. And a table. Now you'll notice there's some options for what I can come out. I can bring out values, columns, or tables. When you bring that stuff together, you can really bring anything out of these data functions. It's inside Spotfire. So you can pull out a column and attach a new column. You can bring out a whole new table or just a specific value. So the rotated values, the rotation matrix, and lastly the components. So the last thing I'm going to do is check my values here, so I make sure they're all tables, and that's a table. Perfect. Okay, so now I've registered a data function. So before I do that, I just want to show everybody a quick, really cool visualization of what principal component analysis is and why it's going to be useful. So there's this great site here that sort of explains what we're doing when we run principal component analysis. So when we get a data set, these points may be all over the place in different ranges and domains. So we have X values and Y values that are all over the place. So what principal component analysis is going to do, it's going to rotate it, it's going to do a bunch of linear transformations on the space such that I have most variation in my first principal component, then second most variation in my second principal component, and so on. This is also a way that you can do auto-encoding or compression, because once you get to a certain number of principal components, you can robustly say, I've explained 70% of the variation in the data set, or 80% of the data set. This is actually how some of the first image compression stuff worked. So you would go through and say, oh, we have a lossy compression, I only care if I was bringing 80% of the pixels, you can use something like PCA. Because it's a linear transformation, it runs super fast. So what it's doing, here's this data set on the left. You can see that it sort of has this diagonal trend. My principal components have rotated it such that the most variation is in that first principal component down here, and then the second most variation in this second principal component. So it's been a rotation of the space. If I mess with these points, it'll actually flip around. So if I put most of the variation on the y-axis, now the y-axis has become our principal component 1, and vice versa. If I flip this over here.
Can you put labels on the points if you wanted to? Like what's point 1 on the left and point 1 on the right?
I will make it very identifiable so you can see it. How about that? Because I don't think I can put labels.
Yeah.
So this is going left to right. So it's just rotating that stuff for me. So what I'm going to do in high multidimensional space is rotate that data set and reorganize it such that I have my axes in descending order variation. That's going to be really powerful because I want to do clustering. So this is important for clustering because if I want to find patterns, it helps out because I'm auto-normalizing, I'm rotating so I know what's the most important dimensions. This is a really good way to run the clustering stuff. Okay, so let's do this inside Spotfire. So we created this data function. Now I'm going to hit run. Now running it says, okay, embed yourself inside this DXP that I'm building, and anybody I share this DXP with will automatically be able to run this too. So that's the really cool thing about it. They won't need any extra files, they'll just be able to open and run it. So the first thing I need to do is match the data going into it and the data coming out from it. So I need to say, select my columns. I'm going to go through and add a bunch of these numeric columns. Because I told Spotfire that I can only have numeric columns, it's only giving me numeric columns to choose from. So I'm going to say OK. And then here, I have rotated values, I have the rotation matrix, and I have the components. So rotated values are actually the updated values for each of the rows in my data set in new principal component space. So I want those to actually come in as columns to my existing data table. That's going to give me a lot of power in just a second. We'll see it. I'm going to do it on time. Okay. All right, so hit OK. We run it. Now let's take a look at the results. These are my principal components. Alrighty, so now you can see we have these different principal components, and at about 3 principal components, we hit over a little under 70% of the variation in the data set. So that means the multivariate model that I'm going to make, because I'm going to make a linear regression, probably needs about 3 or 4 columns. It's a rule of thumb. It's not actual. If I wanted to see the important columns that have gone into there, I can look at my rotation matrix and actually see which columns are important for which dimensions. So principal component 1 is on the x-axis, principal component 2 is on the y-axis. I can see which columns go into creating each of those principal components. Now, this is something that's really powerful inside Spotfire because once we have this, I can actually cluster in principal component space and see it on the map. Let me go ahead and do that. So here, I can actually put in PC1 and PC2. But before I do that, let me show you one more chart here. So this is our original data set, and now I have these additional components, PC2, PC1 there. So this is my existing data set just in principal component space. So I rotated it. So I'm going to cheat a little bit and bring in some code that handles some missing values that I wrote earlier. Okay, now it handles missing values for me. So at this point, we're now clustering on our principal components and not just lateral length. These are much more informative clusters. And now what we want to do is actually see trends in space. So we're going to have one more step here. What we want to do is actually build a heat map behind these points and understand the trends of those principal components. So luckily, we don't have to build that from scratch. If I do, I end up on the TIBCO community site. And so they have this really great, they have this really great heat map function that we can just download and use. So to do that, I'm going to download the spatial heat map. So that's downloading. So you can just download this. Now I've already downloaded it, so I'm going to grab it real quick from the file. So I'm going to go through that same process. I'm going to say registry data functions, import. But this time I want to import it from a file. So this is the download file folder that I got. And then I get this SFD. And when I open it, it actually has all that TERR code already written. So some awesome data scientist already wrote 261 lines of R code. And I can just immediately put this into my Spotfire analysis and match it up to my data. So X is going to be longitude, Y is going to be latitude, Z is going to be, we'll start with 12-month fuel oil, and then smooth scale. And the output, I want all these to be new data tables. So I should have gotten some new tables. Let's take a look real quick. So I have new tables in here, heat map, contours, and other things. So I think that was one that, if we skip ahead, once you bring that in, so I've loaded in those principal, that heat map data function in the background here. So here's my heat map, and this is the script that we plugged in. And now we can actually build some more document properties and look at those principal components in space on the map. So very rapidly, we can build this analytics app and connect it up with many different data functions. And so we went through the process of clustering, running a PCA, bringing in the heat map, and that took me under 20 minutes. And this is something I can save and share very easily. Very good, very good, very good.
I'm now going to extend that, that PCA to an autoencoder, deep learning autoencoder. And in a pre-built application that took a couple hours to write rather than a few minutes. And let's see what we've done on this one. I lost my glasses somewhere tonight, so don't worry. Really like it now. Okay, so let me change my resolution here. Let me see this stuff. Okay, so I've got a bit of code in our studio, but let me show you the application in Spotfire. We can jump back into our studio and take a look at that later. But this is some data coming from a bunch of logs, and well, in fact, yeah, I think that's a problem. It's okay. This can you pull that thing back? Okay. Actually, yeah, it's okay. I'll just jump into the demo. I'll show you the slides later. So there's a bunch of data coming from a bunch of logs. We've parsed out the data and we've created these columns, which are reading and finding text values in the records. So we've got about 100,000 records, and we've parsed them out to create about 70 columns. And the 70 columns have to do with the description of the alarm that went off, the equipment where the alarm went off, the IP address of the equipment, anything else that we're able to find, in the log file that described the condition of the equipment at the time. I'm going to put date time in as an ID column to keep track of the date. Then I'm going to put all these in to an autoencoder. Now, an autoencoder is just like a PCA, and except the hidden layer is the number of dimensions. Troy did a PCA on five dimensions or so. We're going to fit a neural network that has 10 nodes in the hidden layer. So we're going to reduce the dimensional space from the 70 or so variables down to 10. We're going to describe in low dimensional space, that high dimensional problem. Now the cool thing about the H2O autoencoder is when you bring in those 70 or so variables that I've found from parsing the logs, it automatically does one-hot encoding and strings those out from the 70 variables that I discovered in my parsing out to a couple of hundred with 0-1 columns. So it creates the 0-1 columns for you automatically. So you might have a column that has 5 unique variables. It'll create 4 columns with 0 and 1s to represent those 5 columns. So unlike Troy's thing where he just focused on the numerical ones, I'm going to bring in all of them, whether they're numeric or whether they're text or whatever. I'm going to want to encode them through H2O. So I'm really reducing the space from about 500 dimensions down to 10 with the 10 nodes that I have in the hidden layer. Right? So that's the setup of the problem. And then when I run the analysis, I pick off the epochs, the hidden units, the penalty, the rate decay, so 10 units in the neural net. And now I get back the reconstruction error. So as Troy mentioned, these sorts of dimension reduction techniques were used in the early days of image compression. So if I can be 80% accurate with a really fast algorithm, I can reconstruct a high-dimensional space with a low number of dimensions. So I'm going to reconstruct with 10 dimensions this kind of messy, nasty problem of text files with descriptions of outages and system equipment conditions that contributed to that. Now, when I get a very low reconstruction error for a point, that means that the weight of the data is well representing that point in just 10 dimensions. If I get a very high reconstruction error for an individual row, we've got about 100,000 rows of data here. If I get a very high number for that, it means that the 10 dimensions is not really representing that one very well. So that's an outlier, that's an anomaly. So this is an anomaly detection algorithm using a generalization of principal components called autoencoder analysis based on neural networks that does that same dimension reduction that Troy did, but now we're doing very generic inputs. We're not just doing numerics, we're doing log files, cars log files, 500 dimensions down to 10. So these ones over here, if I plot the count of the rows related to the reconstruction error, the ones that are down near 0 are ones that the 10 dimensions fitted very well. The ones that have a high reconstruction error over here, these are observations out of the 100,000 that weren't fit very well in the 10 dimensions. These are the anomalies. So if I'm doing anomaly detection, these are the anomalies out here. Now the H2O functions that do this, there's a H2O deep learning function which does the fit of the 10 nodes, gives you back the fitted values, and then the H2O anomaly function gives you, in addition to the fitted values, the hidden layer. So if I go down into the features here, I've selected columns that are informative, the description of the error, things like that. I could also get the actual 10 components of the hidden layer. I could look at those hidden layers, just like Troy looked at the principal components. I could look at the features that the neural net automatically generated and see what they look like. They're kind of weird, actually. If I look, I'm really interested in the ones that have textual information, diagnostic information about the anomaly. But I did start playing today and drawing up some of these, some of the hidden layers, and you can see these weird and wonderful patterns that start to occur. And I can also plot them versus the reconstruction error. You can see what they look like in different PC space. And you can kind of explore the hidden layer in that sense and how that's representing the anomalies. But let me go back to the real stuff. And here now I've gotten these anomalies out here. I've detected them. I've drilled down into the text that's showing them. And now I can put the reconstruction error here out on a time series plot. So I can look for these early warnings of the anomaly. So here's where the network actually went out of service. But earlier on, if I plot the reconstruction error versus time, earlier on I'm finding early warnings of the network about to go out. These are degradation. This is an outage. These are degradations. And I can see from my reconstruction error plot versus time that I had these early warnings. Now I can start to now trap for those. I can set up a model that can be stored on real-time data to kind of trap whether those were, we were seeing those early on. Now, I can now also take that reconstruction error, and I can use that as the Y variable into a gradient boosting machine or any other machine learning function. So I use the reconstruction error now as the Y variable, and I can put those same factors, those 70 or so factors that I got from the log files, I can now have those as X variables in a machine learning model, and I can explain that reconstruction error. So firstly, I've identified the anomaly as a high reconstruction error, and now I'm modeling it as a boosting machine to find out what are the important variables that are predicting that anomaly. So here I've got the variable importance plot back from the boosting machine. I can see it fits the model pretty well. And those are just the GBM settings. You can play around with those. You can expose these through Spotfire as well. And now I've got, a GBM explanation of the, autoencoder fit and reconstruction error. Now you can make this dashboard more friendly. You can put in, plots, for your business user if you want. You can sort of start to show, where did those anomalies occur on a map of the US where you might have the network configured. You can set up these KPIs and so on, understand the details around the call, that sort of thing. But yeah, that's the general idea. Is we've now extended from Troy's analysis into a more high-dimensional data set with a fancier algorithm. So if we jump back to the slides, Troy, and I've got my RStudio. Before we jump back, 1 second. See that I took so much pain to get my RStudio stuff working today. Here's the R code that I wrote that calls the H2O function. Here's my neural net model with the H2O deep learning call. I can look down at the results, of my, as I build up the results table. I guess, what is it? NN model. It's got my fitted statistics. I've got an overall mean square error of about 0.03%. So that's the average between the ones that are really well fitted and the ones that weren't well fitted. You saw on my reconstruction error plot there was some chunks of fit and not so good fit. And then I can start to understand, in RStudio, I can build this out to my heart's content. I can, I look at my result data set and study that in detail, which has in it, those text fields and the alarm trap descriptions, with the subscriber gateway error, all those text fields that I had in the analysis. So all that stuff that I showed you surfaced in Spotfire as I drilled down from the high reconstruction error into the descriptions. This is directly coming out of the H2O results table, surfaced through the R script inside Spotfire. Okay, we can jump back across now then, Troy. So, we've tried to build up the talk tonight from hands-on, simple data set, construct a basic PCA that represents the data in a reduced dimensional set. I think Troy had 3 or 4 components in the principal component analysis from a data set with dimensions of about 20 variables, something like that. What I did, Troy also used this contour data function to display on the map that you can download from the community site. These are other examples of data functions that we use for specialized applications, like in the manufacturing sector. We do these wafer maps. These are configurations that we use through Spotfire. It's a data function. You put in the die width, the die height, you get back a wafer map. You can then color and smooth that. We use the fields, thin plate spline function from the fields library to do the smoothing. And you can represent lots of different constructs that are useful in the manufacturing sector. And every industry you can make your own graphs for. Combinations of R code, maybe write out your R code into a shapefile, bring that into the map chart in TIBCO. It has a layer on the map chart that you can write to. You can do calculations with R on those layers like Troy did with the contour. You can do heat maps, smoothing, work with the layers inside the map chart. So what I did was to extend Troy's thing, was to take all these weird log files, parse them out, create 70 columns, feed in those into a single layer neural net using the H2O deep learning library with 10 nodes, so 10 features, and then predict each of the inputs, so 100,000 rows of observations. We predict every one of those, and the ones that are a good fit, no low reconstruction error, have been well represented, they're not anomalies. The ones that haven't been well predicted, the reconstruction error is high. Those are your anomalies. We can plot them versus time, see when the network started to degrade. So we can use the predictions, we can use the prediction features and the reconstruction error to identify the anomalies and then start to understand the anomalies in context of the problem. So we use the H2O deep learning function, autoencoder equals true. We source that through the TIBCO R engine. We use the H2O anomaly to come back and get the predictions and the features. And that's what gave us the results there, the reconstruction error versus time. The ones that have the high error, again, are the ones that we drill down into. They're the ones of interest. We've got this early warning sign of a subsequent network outage. And then we can also take that reconstruction error into the gradient boosting machine, get out the variable importances that are really explaining why those anomalies were occurring. So it's a two-step process of the neural net followed by the machine learning to get at the heart of the issue. So we have a bunch of these types of data functions. What Troy did and what I did tonight, these are available on one of our community sites. We try and split up the work so that we don't do the same thing. So the anomaly detection and the gradient boosting machine are functions you can get from the TIBCO site. The other ones coming from the Ruths.ai site. You download these to your heart's content, play with them. And we've been pretty successful with this combination of TIBCO Spotfire and R and the geo stuff, especially in Troy's area, in the energy sector and the high-tech manufacturing sector. Engineering people seem to gravitate to this. They want a little more than just your basic dashboards that some of the other visualization tools provide. And so we've been that successful that we decided to buy a company to kind of make it double down our bet in this area. So we acquired a company, Statistica. We've got a couple of guys from the Statistica acquisition here tonight. And the idea here is that if you don't want to take the trouble to write that R code, that you can point and click your way to get the same model. So Statistica has this wonderful data science workbench. You drag and drop and click your way through. So here's the same H2O gradient boosting machine here, but now it's a click operation rather than writing the code. And it has thousands of those point and click models inside of it. More importantly to me, in bringing this company in, was the fact that the code is managed in this metadata repository, and the point and click code is managed, but also the R code and the Python code. So all the stuff that Troy and I did, we can stick it into an R node inside Statistica, save the workspace into the Statistica library, and that is also managed, and you can reuse it, and it has things like version control, deployment, embeddability, validation, audit logs. You can log in and get access to anyone's workspace or model that you can then use back inside Spotfire. So the comprehensive point and click stuff was somewhat interesting to me, but as an R and Python developer, the more interesting part was to the management of the lifecycle, the security and governance that you get with it. And so just to walk you through how that works, so say I create one of these workspaces in Statistica, I've created a model, I've created a workspace, I can now deploy that and manage that model. In fact, inside the Statistica, when you publish to the Statistica Enterprise server, you can take, some of these things can be run down in the database. So the Spark stuff can be run through MLLive or H2O down through Spark and Water, run inside the database. So whatever workspace you create, and there's also a rules builder. So if you don't want to have a complex machine learning model, there's an interface for just building a rule. So the rules and the models are both then managed inside the metadata repository on the Statistica server, and those rules and models can then be used to do a batch scoring of a model that you put in there, a real-time scoring, send out an alert. You can also publish the model out as PML or Java or C or even SAS, publish that out into another TIBCO product. So if you have a service architecture deployment around your organization, there's the model management the Statistica provides allows you to then manage and version control that as you deploy that out into the rest of your infrastructure. And you can also push out the results out to Spotfire. We have the ability from Statistica to write out a Spotfire binary file that goes straight into Spotfire for taking that machine learning model you built point and click and now incorporating into the same sort of workflow that Troy and I showed from our scripting. You now have a point and click way to generate those models and include them into the rest of the workflow. So in the manufacturing space, we do a lot of statistical process control. So you build out that, say, in Statistica, push it into Spotfire, and now you can have your automatic brush-linked control charts for managing a bunch of variables on the manufacturing floor. Or from inside Spotfire, you can call out to the statistical workspace directly and have that populate results back into Spotfire and complete the loop in that kind of way. And then our StreamBase product, this is our event processing product. You can push out the PML or the Java code into a StreamBase event flow, and as real-time data comes in, you can apply that on a window score that model. If a threshold is violated, you can send somebody a message to go call on the network and fix it. So that model that I had there with the outages, that could be running real time and sending you guys notifications on their cell phones. Hey, this piece of equipment looks like it's in trouble. Go fix it. So this is the real-time part of the TIBCO stack. And that comes with live charting. So in the IoT space, going from this world of Spotfire and Statistica and R out to StreamBase and out into the edge where you're managing a bunch of equipment, is kind of important. And so this is a whole IoT angle on what we've shown here tonight. So the way this kind of fits into the TIBCO stack, just to tie it in context, we are TIBCO tonight after all. We've seen our visual analytics product, Spotfire. We've seen our predictive analytics product, Statistica, along with TIBCO Runtime of R. We've seen how that gets put into our streaming infrastructure and gets embedded. The other half of the TIBCO business, we're a few thousand employees, more than $1 billion in revenue, so we've got our analytics stack, we've also got our integration stack, and so you put these things together, we connect to things, we sense them, we learn from them, and we take an action. So the connect part, includes our products like BusinessWorks. The other products also have those connectors in them, but we can connect to a bunch of things with those products. Spotfire, you can start to understand visually what's going on in your data, wrangle the data, do dashboards, geo-analytics, predictive, build those apps that Troy and I were building tonight. And then you go on out into the predictive world where Statistica plays a role, machine learning, text analysis, SPC, model and rule development. That's where we start to learn and codify that stuff. And then we take an action, we publish that out into a real-time infrastructure, an event processing product. StreamBase, for example, can connect to real-time data, score those models, send out notifications, and keep the network running. So you put all that together, that's what we call our TIBCO Connected Intelligence, going from connect to sense to learn to act, from Spotfire, into Statistica, into StreamBase, Live Data Mart. These are how the TIBCO products tie together into what we call Connected Intelligence. So, to wrap it up tonight, thanks for sitting through those demos. It's pretty quick to get started on this stuff, and we've created accelerators for you to get started. On the TIBCO side, go to community.tibco.com. You'll see all the functions that we used tonight. You can download them and use them. There's this community wiki, all the different aspects, how to start with Spotfire, wrangle data, viz, mapping, predictive analytics, different industry focus areas, how to do the dashboarding and themes, geo-analytics, a lot more stuff that you can do. Sky's the limit with this set of products. And I think there's the stuff we used tonight, the boosting machine, some of the other downloadable applications that you have using Spotfire or the rest of the TIBCO product stack. And then Troy, you want to say a couple of words about the exchange? It's pretty awesome what Troy's been able to put together on the back of Spotfire as well.
Yeah, so as you saw, we were able to quickly build an analytic app. And what we've developed is an app store for those apps. So it's actually third-party app store. We have lots of independent contributors in addition to ourselves that put up apps for all different types of different problems and solutions. So we have stuff that are just basic visualization all the way to the fancier data science things that we talked about today. So the nice thing about that is there's over 60 free things on there, but then there's also a lot of things under $10 that you can go pick up. A lot of the popular items we see are making your Spotfire dashboard look nicer. So like full-out menus, some nice interactive graphics. And then we also have lots of extensions that add some extra capability to Spotfire as well.
Yeah, and Troy also has work from other partners. So he's kind of arm's length from us as a separate company. But other vendors and partners have got their stuff up there on the exchange as well. So things like natural language generation and things like that. So here's the last slide. You can take a photo of this one. This is where you go to get the stuff from tonight. We featured the anomaly detection template, bottom right, the gradient boosting machine template, bottom left, the PCA and Spotfire in the middle. There's a bunch of other stuff that you can get. Just go download to your heart's content. And then feel free to also drop Troy and I a note. As Troy said, we spend a lot of time in meetings and doing business stuff, and it's really fun when we actually get to a few hours to kind of play with data. And so Troy's been here the last couple of days, and we've actually just been jamming on data together. It's been awesome. So thanks so much, Troy, for coming out, and thanks everybody for coming out too. So Aaron, we've got a drawing, do we? Will I do the drawing? All right. So we've got a GoPro to give away here, so that's an encouragement to stay to the end of the talk here. So let's see what we got. Ticket number 6685491. 6685491.
Does it have to be exact?
It has to be exact. We don't have that one, huh? All right, we'll have to try again, really? Okay.
Oh, wait.
Oh, you got it. All right. Gentleman over here, where are you from? Brazil. What about what company? Charm. Yeah. Okay, come on up. And,
Do you have your ticket?
you got your ticket? You got your photo ticket? Is this, no, that's 451. 491. 66. It was a little bit dodgy there that he only had a photo on his camera too, I must say, but anyway. 6685491, no?
Michael, he just compressed the number.
Was that, yeah, PCI.
Yeah, that's right.
Maybe just the last 3 digits.
Last week, okay, 460.
What? Last two?
460, this gentleman right here. Come on up, come on up. Give this guy a round of applause, huh? So, where are you from? What's your name?
My name is Alex Karmazic, and with Night Capital, we are doing risk analysis for small companies.
Yeah, Night Capital, that's a big TIBCO customer. Yeah, thanks for coming along. Yeah, you guys had a real you had a flash crash that we helped with there on Wall Street there a few years ago. Hey, great to try shaking hands on.
Yeah, that'd be great.
Couple of my arm around, but I thought that might not be PC correct.
Thank you.
Okay,